Hello students and welcome to Unit 4. So this unit we're going to start talking about molar mass and percent composition. That's this week. Then we'll hit grams to moles, moles to particles, molar conversions. You can kind of see an outline there of what we've got going here. So let's go ahead and jump right in to molar mass. So here we have molar mass. This is the beginning of 4.1 or beginning of Unit 4. We're on page 23, and for right now, we're going to start off, our unit is called moles, so we're going to define moles as an amount of substance. As we go through this unit, we'll get a little more in depth to it, but for right now, we're just going to call it an amount of substance, which is true. That's not going to change. It just might get a little more in depth. So let's go ahead and talk about molar mass. Molar mass is abbreviated capital MM. All right, capital MM, that's molar mass, and it's to keep it real simple, how much a compound weighs. And I do know that weight and mass are different, but for our purposes, this is going to work out for us. And plus, I didn't want to use mass in my definition of molar mass, but we're talking about how much it weighs. So some background information. We're going to be using the atomic masses that are found on our periodic table. So if you don't have your periodic table handy, go ahead and hit pause. Grab that and a calculator because you're going to need both. But atomic mass, remember, is that bottom number on the periodic table. All right. It's also the one that shows us how much an atom weighs. Looks like my writing is pretty atrocious right now, so we'll try to fix that up a little bit. And so where do we find it on the periodic table? Remember I said that was our bottom number. All right, that's the bottom number, or the one with a decimal, kind of depending on the one on the wall in the classroom. It's red. It's in red. Okay, so a couple other things to review here is counting atoms. So we have ammonium phosphate there listed for us, NH4 parentheses 3 parentheses P8. PO4. So how many N's do we have in this formula? Well, remember the parentheses are distributive. So we have 3 N's. We have 4 times 3. We have 12 H's, 1 P, and 4 O's. And we need to know how to do that so we can do this next part. So let's talk about finding our molar mass. It's very, very simple. Little addition, little multiplication. We're set to go. So here we go. Steps for finding molar mass. Our first step, and this is why this last unit was so important, we must write our formula. After we write our formula, we're going to separate our formula into elements, kind of like we did above. Count atoms of each element, then multiply the number of atoms by each element by their atomic mass, then add it up from D to get a total, and then label with grams per mole. The other thing that we're going to do is we're going to keep, didn't know I was still on the highlighter. We're going to keep 2 decimals, all right, just to keep it fairly simple. Our molar masses, we're going to only have 2 decimals on, so we're going to keep 2 decimals. So let's start right here with water, all right? Hopefully we know the formula for water. We've got H2O. If we want our covalent name, it's dihydrogen monoxide. So we've got H2O, that's our formula, and we split it up into our elements. So we got H and O, and I like to give myself a little space in between each element, all right? And that'll make sense as we grow through this, all right? So now we have 2 H's and 1 O. Hopefully you agree with that. We have 2 H's for every O on there. Now this is where we go to our periodic table. We look at our periodic table, we see H is 1.00794. Okay? And we see O is 15.9994. All right? So we're going to take 2 times 1.00794, and yes, we are going to keep all those decimals for right now. And so we're going to get 2.01588. No, 1 times 15.9994. Hey, that stays the same. We're going to add those 2 up. And we should come up with all the decimals for right now, we'll do our rounding in just a second, 528. All right. Keeping 2 decimals, we're going to get 18.02, and we're going to label it with grams per mole. So we've got it there. 18.02 is our molar mass of water, grams per mole. So let's try a little bit tougher one. All right. This time we have iron 2 chloride. So we're going to have to do a little work here, maybe a little tougher. So we have iron, which is Fe. Remember, this 2 is plus 2. That's the charge for iron. Then we look up, we've got chlorate, which is ClO3. It's minus 1. So when we do our crisscross, we get a 2 here and a 1 there, right? So our overall formula, Fe, parentheses, ClO3, parentheses, 2. Take a second, make sure you understand that. Got that? Okay. Now we're ready to break it into our elements. So we have Fe, and we have one of those. We have Cl, right? Cl, not Ci, because it's chlorate. So there are 2 chlorines. And then O, we have 3 times 2, which is 6. So we have 6 of those. Now we go to our periodic table, and we fill in our atomic masses, which is obviously going to be 55.845 when we multiply it by 1, 35.4527. And so when we type that in, $70.9054, and here 15.9994, and we'll take 6 times that. And I do encourage you to write it out like this, because what we do tomorrow, we'll use these numbers here, so it's kind of important to write them out, because like I said, we'll use these numbers here tomorrow in our notes, percent composition. But for today, we're just going to add these babies up. So we got 95.9964 plus 70.9054 and plus 55.845. And we should get, add it all up, 222.7468. And then if we keep our 6 bigs, 222.75, and that's going to be labeled grams per mole. So molar mass is fairly simple as long as you know how to write formulas. Okay, awesome. See you next time.